How are you doing? Hello.
Hello.
Hey, how are you doing? Good to see you. So I think 3 of us, just that's it. Small group today. Let's begin discussing. We'll begin. So let me quickly check a couple of things here. First thing first, I want to project my screen, which I am not doing right now. So let me go do that. And then I will focus on this virtual machine and illustrate a couple of points, and then go into discussion on a different topic, which I think we will discuss Docker today with specific examples of building out a collection of services. And you will see how easy it is to actually construct whatever design you want. Like we have been always discussing about some outcome. And so we took the trouble of designing nuts and bolts of a specific service, like running WordPress on some cloud and giving that to the customer. So that's the outcome we wanted. But the way we assembled all these components was using Chef. That was the deep dive we did. However, what we want to discuss today is this concept of containerization first, and then understand what does it take to construct whatever we feel like using the container technology that this thing called Docker provides. Docker.com has a solution out there for us that we will use. So here is the Docker website. The open source is available on GitHub, and you can see the project as you've probably seen it already before. So go to GitHub and see Docker, and that is where the source code is, which is, it's hiding somewhere. Yeah, but let's go subject, Docker, there. And so it keeps updating every frequently, like 2 hours ago it got updated. So you've seen it's open source. But similar to this technology, there's another one called Rocket. And there are more. There are technologies like this, that compete. Now this is very popular, this is not so popular quite yet, but it is also a very good service, a good product. Open source again, Rocket. The name is Rocket. And what these things essentially do is help us use containers. Now, container technology itself is not new. These tools enable ease of use of containers. Ease of use of containers. That's what they do. They are not container technologies themselves. The underlying container technology, as you probably know, is LXC and LXD in Linux. And that technology itself is not new. You've probably seen me talking in another video. If not, I will just paste a link for that for you. And I think that should be in the library, but I'm not sure you've seen that. There is a session I gave a couple of weeks ago on this subject, introducing basically one-on-one beginning session. And that is posted here in the library section that you can see. It is publicly accessible. You should actually take a look at that. So I'll paste a link for that in Slack chat. I think some of you have seen it, but I'm not sure if everybody has seen it. So you should watch that video. It's a short 20 minutes video on introducing people to Docker. But I don't think you need to watch it, but it's a good idea to just give it a shot. And that's this video. Now, having said, what I want to be able to do is use these technologies, specifically this one, and understand how do we construct outcomes of a variety of different types. That's what I want to really be able to do. And so just quickly checking if other people are yet online or they're not yet here. So we have only David, Ram, and Mukesh. Other people are missing. Okay. I don't know what may be the reason. The weather seems to be okay. I mean, there is no outage that I hear as such. But yeah, we are recording the session, so I think we should continue. Maybe I'll just quickly ping one-on-one and see if there are people available. No, she's out. He's out. Okay. They're not on link, not on this thing called Slack. So yeah, Dennis just joined. Hey, Dennis. He's still joining in, I guess. But we'll keep going forward with what we're discussing. So the discussion I want to really have is to be able to construct, as I said, a variety of outcomes, and we will begin defining what an outcome we would like to have for the customer, and then construct those outcomes. So the exercise we did in the Chef, using Chef, and we constructed the entire stack and all that. That exercise can be very simply put in form of just one container. Single container, one command, and it brings it up. You've seen it before in a quick demonstration that I may have put, but I want to go deeper in that. And that demonstration, I think, is this thing called Tutum WordPress. You may have seen it before. I would like to run it in a greater depth. And here is the code for that. And what we need to do essentially to run something that runs WordPress is to run this one line, and that should do it. So we'll take this line of code, bring it here in our workstation, make it a little wider so you can see properly, and then check if any process is running on port number 80. So I'm quickly checking if something is open on port number 80 by opening up Firefox and seeing whether there is something on the local host running on port number 80. So if there is nothing on that port, which is nice. So that port is open and basically available for us to consume. So we will use that. Right now, nothing is running there, which is good. So what I want to do now is run that quick container. Like I said, I want to run WordPress right here, right now, one command, and please go do it. So it does it, and it is running right now. And so we should be able to open up browser and go to localhost and see WordPress and refresh. And you see that it is not showing you because of some other issue. But let's see what that issue is. Open, please. And here it comes. So there was just a refresh issue. And we refreshed and we saw WordPress. That is great. That is great. So just one line does it. But what is going on under the hood? That's the real question. So I want to go deeper in this to understand. And it is not that complex, as you will realize. It is actually fairly simple to put a clear understanding of what this one line does. And I would like to rewrite this line in a different fashion. What I would like to do is take this notepad and reconstruct that item in a separate fashion. I will rewrite the whole thing, just one line, in a different fashion. And that what I want to be able to do is, I'll get rid of this open folder. So I'll remove project and close out all these guys. And even this one, and don't save. I don't need to save any of these, so cancel. And go away, don't save, go away, don't save. Yeah. So we now have an empty location to save something. That's the line I want to reconstruct. And I will do that in a fashion. I'd like to understand what goes in building these things that we just saw. So what is going on under the hood? So we have this executable called Docker that runs something. What is it running? It is running some image. What is that image? That image is called this. And it is created by this entity called Tutum. And the image name is called WordPress. It is running like a daemon. Oops. Come back again, come back. And running like a daemon right there, like -D option. And also mapping the port number 80 on this computer to the port number 80 inside that container. So real machine container. Virtual machine, container. That's the port mapping. Real machine here and container here. Virtual machine here in our example and container here. So if you have a real box, this is the real port. This is the port that goes to the container. So you can see that detail here. If you go and say docker ps-a, and you will see these things right here. You will see that this is the container ID running this image, running some command created 2 minutes ago. Status is up and running because we ran it like a daemon, line number 5. And ports are mapped like this. Anywhere on the internet, 0000, as long as they access this box, which is the physical box here, like line number 7, port number 80, this one, that you will map it forward to the port number 80 inside the container. So this is the inside the container portion. This is the outside portion, the actual box portion. And this is a comma separated, another port exposed. And that port is 3306 for MySQL database, and it is strictly within the container. There is no mapping to that one on the world outside. You can map it like so, if you want to, but you don't want to because there is no reason for it. There is no reason to bring that one outside. You could bring it outside like by doing this, and you could expose it to the world outside, to the machine outside by opening it up and writing line number 9. This port will get exposed. And you can very simply do that by saying, you know what, let me kill this guy first. So let me kill the running container. So docker run rm-f and 89. I'm killing that. And this time I will start a new container, but then I'll introduce this new -p option, which is 3306:3306, and then run it. And now I will see the difference. What I just did was a port mapping. Port mapping, port number 3306 from the machine outside, mapping to the 3306 machine inside, the container inside. That's the port mapping it exposed. You see the difference between this segment and this segment. That's port mapping we just did in line number 9, which is exactly this portion. So we're able to map port like this. But what is going on under the hood? Under this, where is this thing coming from? How is that constructed? And who built it? And why did they build the way it is built? And so all these questions, we need answers. So how will we go find out? These images are coming to us from a central location. This line number 3 comes to us from a repository. That repository is called Docker Registry, also known as Docker Hub. We should go there. And we'll open a browser, go to Docker Hub. So in hub.docker.com, we should find Tutum WordPress. And there it is on the Docker Hub. And that is where the image is available. But on that same location, you will find a link to GitHub where the source code is available. So this is Tutum company, which got acquired by Docker, by the way. So this Tutum was a company, it means attitude in Turkish, Tutum. And this WordPress is the image that they constructed for us. Now, if you go look deeper on where this source code is, let's go find that out. Which is also surprisingly very small and very simple. We will see that source code available to us. I'm getting some echo. Hey guys, I think one of you can mute. Okay, I'll mute you. Thank you. So what I was talking about is this image that you saw that we just used is actually available in source code form also. it is available in GitHub in that location. If you go look for it in the repository on Docker Hub, there will be a link to GitHub. So we'll take that link and go to GitHub like this. And you will find a repository here, which is a Git repository. You will see the source code. In that location, you will find that there is a interesting file available called Docker file. And this is the basis on which you're basically building images ready for distribution. And you will see that here are steps written down that need to execute to construct an image. And this is basically the equivalent of one page, 42 lines of code, 42 lines specifically. And these construct a WordPress stack for us based on beginning from Ubuntu Trusty. That's where it begins. And it constructs a complete stack running WordPress. That's what you see when you run that stack that looks like this when it runs, like this when you execute this one-line command. So under the hood, we are essentially looking at a file called Docker file that builds whatever we want. And like this, we can start looking at other examples as to ready-made solutions people have put together and are using. We'll begin using ready-made solutions for the first maybe 30 minutes or so. But then we will construct our own images as we go along. So for some time, we'll use existing images, and then we'll go deeper in construction of our own scenarios, our own constructions of our own images, our own services that we want to be able to run, and then deploy them all in the context of Docker. And you can see how easy and simple it can be, but it just needs to be understood a little bit. More concepts need to be understood before we start assembling our own images. It actually is pretty darn simple, but I want to clarify a couple more points before we jump into the construction of our own images. I want to ask you this one question, which is, did I ever create an image for you, with you already or not? Did I do that or not? I'm missing out.
No, we didn't.
Did we ever create any image?
I don't remember.
Okay.
I don't think we did.
Okay. So let us create a very simple image right now. And so in this notepad that we have, I'm going to erase and begin creating our own first image. So we'll call it begin on the foundation. I will begin on some good, well-known starting point, such as Ubuntu and 16.04. That's my starting point. On that, in that image that is like a well-known community-provided operating system image, I will then make a very, very tiny change, really tiny change. Something like create a file, right? So I'm going to copy this file over to the root location. And then that's it. I mean, that's the only thing I want to do. So I will save this file in a folder. Let's call it the user folder. And in there, I'll create a test folder for Docker test. And that folder I need to create actually. So we'll create a folder first called Docker test. And inside that folder, we will where does Docker test go? Create a folder, Docker test. And then save this file as Docker file. And save, no extension, just a file called Docker file. Now this file expects when it runs to build an image. When I run this, it will build an image. That's what I'm really trying to accomplish, is to actually build an image. And I will do that right here with you, and you will see the image, and you can actually make use of the same exact image I'm building with you together. And I will share that image with you, and you will see how easy, how ridiculously easy actually it is. So let's go build it. So I'm adjusting my screen layout a little bit, and here we have it, much better. And so as you can see that this expects this file to be available. So we need to create that file like this and save it right next door right? And the sibling of this file.txt, which contains some word, some language here. So we'll write something here. Hello, how are you? Some plain text file. That's it, save, close. So our outcome that we want to accomplish is to construct an image that contains a file called this file.txt inside the root location. That's the only idea I have right now. It's a very simple idea. I want to construct an image different from the standard image, slightly different. I want to put this file in that location. That's the only change. I mean, that is my design. Very simple design, but that's my design. So I want to construct it and give this item in that location. The item I want to give you is this item, which is, hello, how are you? In this file called this file.txt. And I want to copy that file over to the image in that location and pack that image over to give it to you. So that when you run the image, you should be able to receive this image and see that file in there. That's my outcome. That is a very simple outcome. So I'm going to construct an image based on my design. My design is very simple. It is ridiculously simple. Begin from here, copy this file, and I am done. So we will go into that folder. So cd and go to Docker test. And here I will find those two files, which is this file called Docker file. That has to be the name. And then this other file that I want to pass along to you in the image. This new image, I will like to call it, let's call it something, I would like to call it Cloud Genius Docker test. That's it. That's my image name I want to create. So I will like to create that image by typing something like Docker build an image and tag it with this name, and then use this folder to construct it. So that is how my build instructions are. That's it. Now my sharing instructions. Share the build. This instruction is as simple as that's it. That's my share instruction. So I'm saving this instruction for myself to consume in a file I would like to call readme. And I saved it. So that's my third file, which is not really strictly necessary from a technical perspective, but I just created this readme file, which gives me my build instruction and my share instruction. How do I share it with people? And I would like to also include one thing for other people who will consume this build, like you can run this image yourself. I mean, I'm talking to you. I'm saying you can run this image by saying Docker and then run -it. And you can see inside that file that I'm passing along to you. That's the 3-step process. So here we have a build instruction. I have a share instruction for myself. Share this, I should say, share this image. So I should say, oh no, come on, share this image with everybody. And so build instruction is actually build an image. So very, very simple. So I'll run 3 steps, actually 2 steps I will run and you will run the last one, which is line number 11. And we are effectively making use of a method where I construct an image, I give it to you and you run it. And you will be able to see this file.txt, whatever I have here. You will see exact same thing in your image when you receive it. So I will run this build right now, basically construct that image and copy that command over here to the folder we have here and paste it. So it will build the image. And then it will, first of all, it doesn't have Ubuntu, so it will bring down Ubuntu 16.04 right now from the library, and then do whatever the Docker file says, like copy this file.txt into the root folder. And that's it. So the first thing it did, step number 1, was to get the image down from the library. And step number 2 is copy this file.txt to the root folder. Now we have a new image built already. The image has this ID number, but we have given it a tag. The tag is clearly visible to the command, so that image should be tagged already. So we should say Docker images, and we should see that we now have a Cloud Genius Docker test image with a tag that matches the tag we created, which is this ff05, which is this tag ID here that got created, and the interim tag was removed. So it successfully built this container tag by ff05, which is this image ID. It has a tag name, which is this image, and I want to now share it with everybody. So I'll just say Docker push and the name, and it pushes. It pushes to, it says authentication required, so I need to log in. So I'll Docker login. This login basically is a login to Docker Hub. So I'll Docker login, type in my username, get my password in place, and grab my password, provide it to the Docker Hub login method. So copying the password here and typing it in. And this is now pushing that image over to the world outside. Login succeeded. I will now push the image. The image will actually get uploaded. And now you are able to run the line number 11 as simply just like that. So just run it. You should be able to run it yourself. Anybody in the internet can run it, by the way. As long as you have Docker running, Docker software installed, you should be able to run that same image. And the outcome, as we said, is kind of very boring, very lame. The outcome we said is, this file is available to you. I mean, great, big deal. What's the big deal? Not really. It's not a big deal. This file available to you. I mean, that's a method of sharing. I'm sharing an image loaded with this file with you, and I'm pushing that image over to you, and you are going to receive it when you run that command shown in line number 11. And that's what you will be able to do as soon as this push finishes. So it is being pushed right now. And you will see this succeeding. So it just succeeded. So I succeeded pushing that ID number, that long ID. That ID is labeled as this tag. And you should be able to pull it and run that line. And what you will see, I will also run, by the way, here right now. So I will also run it, the same thing here. No, not this, not this. I'll run line number 11. And I will say, okay, run it, please. So run it basically means run interactively and give me a typewriter so I can interact with it like a TTY mode. So this is TTY mode, the T for TTY, I for interactive. Those two parameters together is what you can run, and you want to interact with this image and you want to get a bash prompt inside that image. That's what I really intend to do. So when I invoke this command, I get a different bash prompt. It's the root login on that container ID. And here I can see that pwd. Pwd is the slash directory. So I want to go to the slash root directory. And I should be able to see that file that I expect to see, which is this file.txt. That file is available in the image. As simple as that. You should be able to, by now, have downloaded that and run this one line, which I should actually paste in Slack chat to make it easy on you. And so doing that right now, here we go. And so that command should run and bring the image down for you. This command should bring it. And you should be able to see that the root location has a file called this file available to you containing this content. Hello, how are you? As simple as that. So that was a quick exercise on building an image and sharing with other people. How do we build image? We use this file construct called Docker file and write down exactly what we want. We'll do another exercise, very short one, but at least somewhat more interesting than this one. And that exercise is another link that I want to pull up. And that link is GitHub, Cloud Genius, and then hello, Holy Cow, that's the name, Holy Cow. So this is the image I want to build, I want to pull. So there is a source code available. I'm going to just copy that source code down here like this in our virtual machine. So in that folder that I have, that I'm working here, I will change over to a different folder now. But I want to just quickly check you. Did you run that image successfully? And are you able to see this file inside that image? Yes or no? And that's what I would like to hear. And while you do that, it might take some minutes for you to download this image down to your computer. That might take some time, but it will come. And when it comes, you should be able to just go into the directory called root and find this file and cat it to see the content. That was the design. So we are going to quit and come out of that particular Cloud Genius Docker test. Runtime container. The container is now dead. You can see that code is still running. It's not dead. It is the WordPress is running. So we have to kill that one. This one is dead. WordPress is still running. So let me clean this DCC one also. So Docker rm DCC, and that one is dead. The Docker PS should show nothing. Nice, clean. We'll come out of this folder and close this window as well. And now git clone a different project. In this, another example, but very simple. I'm going to open that folder in the Atom editor. So you'll see it here. I should have close this and open the correct folder, not this folder, but go into the Holy Cow folder and then open Atom in that folder. So in there you will find there are these two files. One is a README file and one is a Docker file. Now this Docker file is slightly more developed than that one-liner we had before. And in this Docker file, what I'm really doing is actually installing something. What am I installing? I'm installing two different applications. One is this, and another is this. This Fortunes application is an application that generates fortune cookie quotes. The Chinese fortune cookie, interesting random quotes, generates that. That's what this application does. And this application is another simple one. It just puts a picture of a cow. That's what you will see as soon as we run it. So that's why I named it Holy Cow, but it's basically another fun way of looking at something very simple to understand how do we install certain things, like here. Install two different applications and then run them. So we have, beginning with Ubuntu, define some environment variables if we want to. We are not really making use of it, so this line actually is not really necessary. We can then update the app cache and install these two applications, Fortunes and Cowsay. And once we have these two applications installed on our machine inside the image, we will then run a command. The CMD is a command that gets executed when you run this image in a container. So that's when this command gets executed. The run command is a run command is a build time operation. CMD is a runtime operation. So this is the runtime. When you run it in a container, that's when this CMD runs. Run command is a build time operation. You want to actually, when you're building an image based on Ubuntu, you want to build these things, it will actually execute this and execute this at the time of building. Whereas this line will get executed when you run that image in a container at the runtime, not a build time. So I want to build this image. What I need to do, very, very simply, Docker build, the tag, give it some name, and then say doc. And that name, I think I would like to give it better. So like I'll say Cloud Genius and Holy Cow. And then build it. And it says, Holy Cow, typing mistake. I don't have a dot at the end. I seem to have a comma by mistake. That comma is inappropriate. So I need to repeat that exercise with a dot in place. The dot basically refers to this current directory, the holy cow directory. It is a way for me to tell, use this Docker file, please, to build the image. So it will, this dot basically says, use this Docker file to build the image that I would like to call Cloud Genius Holy Cow. And fine, it starts to build. It says, yeah, I got Ubuntu already. So let me apt cache update. So it go to update line number 3. It already defined an environment variable called this is awesome true, and running apt-get update right now. And then it will install fortunes and cowsay and denote this line to run at the runtime when the container runs. And we are done. So we are done waiting for this guy to actually update, which is kind of lame. It is slow. It is actually pulling Ubuntu repositories for the update caches to be updated. And then it will actually install these two guys, 1 and 2. Those two applications will get installed inside the Ubuntu container. We'll call it the Holy Cow container. And I will push it over to you, actually to the Docker Hub. And you can pull it and run. You can pull it basically and run just like this thing says. Like here, there are instructions mentioned at the bottom of this write-up that you can follow along, by the way, here. So you can build it yourself like I'm building right now, and you can run your own build yourself locally. If you don't want to build, you just want to run, you run this. You can run it without building because I have built it for you already. And that build is actually going on right now. You can see that the apt cache update finished. And this 2 lines, 1 and 2, will get installed momentarily. At that time, we will have a build ready, and we will have it a name. The name will be what I chose, Holy Cow. And I will push that image over to you. The build has succeeded correctly. You can see that. I'm going to see Docker images. Do I have a new image? And I do. I have a Holy Cow image constructed 8 seconds ago. I need to send that image over to you. So I'll say Docker push. And it goes to the Docker Hub, and you should be able to run it. So it is pushing, and it will not actually make too much change because the changes are only 2 applications. These are the 2 changes, one here and one here, and some apt cache changes and some environment changes. That's what we really have. It's mostly Ubuntu, most of it. So it is mounted from Ubuntu. So only 2 things are getting pushed and pushed and pushing. Everything else is mounted from an existing known image point. So that thing is not sent again and again. So it pushed this, pushed that, 2 references, and everything else was mounted already from an existing image that came from the Docker Hub, right? I used it from Docker Hub, from Ubuntu. So from library Ubuntu, that's where it came from. So it did not need to send that thing which it obtained from that library itself. So it was already mounted from there. So it did not send, it sent only these 2 references that got pushed. And now you have a new image available on Docker Hub called Cloud Genius Holy Cow. You should be able to go and see it here and go to Docker Hub and then search for repository publicly available, or in my case, this repository should be right that one. And you have that repository. It has been pulled by a couple of people already, apparently. I see 17 pulls. And so the source code is available here on GitHub, and the image is available here on Docker Hub. And that's how you pull. And this is how I can also run it, by the way. I'll run it now. So now I have that image constructed. I should be able to run it locally. But very simply, I will say Docker run -it, and actually I don't need to get IT either because I don't want to interface with the TTY. I don't need to get a bash prompt. All I really want to do is just have it run the fortune cookie program and cow say, meaning cow is saying the fortune query or the fortune quote. That's what I really want to run. So I'll say Docker run Cloud Genius / holy cow. And I don't need bash prompt because all I want is to see the quote, the funny quote that I have from the fortunes program, which I'm invoking here, and then piping that output to another application called cowsay. And so it makes it look like cow is saying that cookie quote. That's what it will be. It will be doing. It will run the fortune program, pipe it to cowsay. And so we'll run this just like that. And when I run it, it will run and give you a funny quote. This is Unix we are talking about. Remember, it's not supposed to be nice for the application programmer. Now that was Matthew Danish on Debian development mailing list. It is not supposed to be nice on the people. This is Linux we are talking about, Unix we are talking about. So that's a funny quote, and cow is saying that. That's cowsay. And that's what this command does. That's exactly the purpose in life of this product. And so you can keep running it over and over again, and you will find a funny quote that the cow is saying. What lies on the bottom of the ocean and twitches? The answer is a nervous wreck. Like punning, programming is a play on words. Okay, so that was simple, right? We constructed some image, and you should be able to see the image running on your machines as well. But this is just fun and games. Let's go something interesting, something more important, something more serious. And so what I want to be able to do is help you understand how do we put a multi-tier application inside 3 different containers, and how do you connect them together in a 3-layered architecture. And we will do this in one screen, one sheet of paper, not more than 40 lines. We'll construct all of that in not more than 40 lines, which is kind of difficult to digest this idea. How do you do that? And let us go see how we can actually accomplish that. So I'm going to redraw my layout and get rid of this holy cow. Go change to a different folder, and I will paste a link for you. I'm just identifying that right link for you. Give me a second. The link should be not here. So let me go here and grab it from there. Should be in here. And the thing is called Docker files. So the repository that I would like to download is this. So I'm pasting a link for you. It is in Slack right there. So I'm grabbing that link from that location, which is a public repository on GitHub. Git clone, and I'm bringing that down. It is coming down right now. It came. So we now have a folder called Docker files in my machine right here. So I should be able to go in there like that, and then open that folder in the atom editor. So we have it open on the left side. Now here is something that I want to construct. A 3-tier architecture is what I want to really build. So I will use Docker components to build out a 3-tier architecture. Again, running the same example we did before, and it is WordPress. That same idea, but we want to do it in one sheet of paper that will look something like this. By the way, just a quick look. Here's how it will look like. But I'll help you understand, and no more than 23 lines. And we have it all succinctly described in just 23 lines. How do we do that? That's what I will explain. So in that particular file that I'm looking at, which is actually this file to be specific, 3-tier example, WordPress example, that file, it's also on GitHub that you have a link for in Slack chat. That is what I'm actually going deeper with. But before we jump, I want to read those 23 lines, 24 actually, whatever, 23 or 24, some number of lines. So basically beginning from here all the way to this point. In these set of lines, we have defined 3 distinctly different containers. and have constructed a 3-tier stack of an application you know as WordPress. And how do we put pieces together to construct the outcome that I really want, which is, let me show you the outcome first, and then we go deeper in understanding how do we do this and how does this 23 lines construct what we really expect to see. It is actually 23 lines, not 24. It is 23 lines. So let me take those 23 lines, copy it over, and put that in a file which is basically empty. So I'm pasting it here. It has to have that specific name. The name has to be Docker Compose. That has to be the name of the file. It cannot be some random name that you like. That is the name that you want to put your design in that file in terms of multiple containers clubbed together, connected together in a nice organized fashion, that when you invoke the Docker Compose command will actually read from this file Docker Compose YAML and build what you think you want. So I want to put that file. What I did is, let me show you clearly. I will expand this screen a little bit here and show you what I did is I basically copied from that file into this empty file. So this example I have in 3-tier example, this file, I copied content from here and put that in the yellow item here. That's all I did. Basically, the instruction is to copy YAML snippets from example files and put into this file. That's what I just did. And I'm going to run the stack one line. That's it. So I'm taking that command, one line, copying it, bringing it here, and cleaning it up, opening it, and invoking it. It is going to do its thing, and it will have WordPress ready for us. And we'll see it, and then we'll go understand what did it just do, and how did it do it, and how do we extend it beyond what we just have done. That's what I want to actually discuss. So while it is doing its thing, it is actually downloading. Most of these stuffs are ready-made images, by the way. And you will see that in the example, which is this line, the 23 lines of code. Docker Compose YAML 3-tier architecture example. In this example, what we are really doing is looking at 3 different containers. One of them is just 2 lines. It says build a container to store data. The other one is build a container to store a database. And the third one is to run the application. 3 parts. Let's draw on a sheet of paper now. And the outcome that we are now talking about is slightly different, slightly more involved, not fortunes and cows, but slightly more interesting, like running a service using some application. And this application requires some database. And this database has to be persistent, which means we need to protect the files here. And so we need to have a place for this data to reside and in a persistent fashion. So we'll put that data in a separate container called data. So this is our container number 1. This is going to be container number 2. And this is going to be container number 3, running some application. This is running some database application, basically database server. And the data needs to be persistent. If it is not persistent, we will have data loss. So we want to make sure that we are keeping our data intact, for which we decide that we keep the data itself in a separate container. Everything in a container, every microservice, or however we define components, we are splitting concerns, separating concerns, putting separate things in separate containers. That's what we're really doing. And so these 3, C1, C2, C3 that you're looking at are essentially defined in that file. And by now it should have finished running. So we should now have 3 containers running there. Actually 2 running, 1 exited. So you should see two containers right now. They are, let me do it again. There are two containers. One is the WordPress container. The other is a database container. And these two, WordPress and database. But what about the data container, right? I talked about data container. Where did that go? So it is there. It is exited. So you can see that the container exited 2 minutes ago, and it is the container storing your data. It is the purpose in life of that container is to just store data. It exposes its hard disk storage, and it doesn't need to run, so it exits. It doesn't die. It is not killed. It is exited successfully by doing this command called true. By doing basically nothing, it just exits, because all it is doing is exposing its hard disk. And that's what these three containers are. To give you a clear picture, what I really want to do is actually erase all the running containers one more time and give you a very clear picture as to what we just did. So here I'm killing everything, and then I'm going to run Docker Compose up, and now you should have three containers, two of them running and one exited. So you have this exited 5 seconds ago. That's the data container. You have a database container that is running right now. And you have a WordPress container that is the application running right now. You will also see a couple of interesting things here as to how the connection is wired up. You will see in the WordPress container, which is running for the last 5 seconds, or actually more by now, 32 seconds, is that this port number 80 on the machine is mapped to port number 80 inside the container, because that's what we want to see when we go to that site called localhost. We want to be able to see what the container is trying to show us. And we can do that simply localhost. And we should see WordPress right there. Here it is. You saw it. But this is where it is actually running inside the container. This is what you visit from the outside. You cannot go to the container directly. So that's why this port mapping is important. And that is what this port number 80 is running the WordPress application inside this container, running the image called WordPress. And by the way, it is a ready-made image. The makers of WordPress make an image ready for us. They give it to you and to everybody in a location called Docker Hub, hub.docker.com, same thing. And you should be able to search for it, called WordPress, in the top corner, WordPress. And it is a phenomenally powerful and useful image available, 110 million pulls, details. And here are the details. How did they build that image? There is a Docker file for that. And you can see the Docker file. Here it is. And that's what is running to run your WordPress application. That is actually constructed in an image available in this location that you pulled, that I pulled. And that's what I'm running right here in this container. It has a name, it has this ID, and the image used is WordPress. It has a port mapping between the machine outside and the container inside. Similarly, this WordPress connects to the database here, the database container, separate container that exposes its port number 3306 for the database to be able to connect from outside from this container. So what we are looking at is this container connecting to the database server on port number 3306. That is open, that this server exposes that port so that people in the same environment can connect to it. That's what you're looking at. This is how the application called WordPress is connecting to the database server. That port. It is running in this container ID. The name is Docker Files DB1. It is based on the MySQL image, version 5.6. You can see that MySQL also provides a ton of images. MySQL, which is now acquired by Oracle, and they give you this official image, MySQL image. which is running 10 million plus polls. You can see the details. Here's the Docker file for it. This is version 8. You want to go look at the slightly older version. We're using 5.6. Here's the Docker file for that. And it was created 6 days ago. And that Docker file is available. The Docker image is available. We are using it. It was pushed 4 days ago. It's a fresh image constructed for us. And we are running it right here in the database container, running the MySQL 5.6 image and exposing port number 3306 so that the other guys can connect to it. That's the whole purpose of that database server. It runs MySQL server. That's pretty much it. That's what it does. Let's go understand some things in a drawing fashion illustration so you'll clearly get the picture. The picture is like this. You have a container running WordPress that exposes port number 80 to the world outside, and the world outside is actually a physical machine of some sorts, and it has a port number 80 exposed to the people like you and me. And so you open Firefox here, and you go to the port number 80 on localhost that is mapped to this mapping. That's what you're looking at. It goes to this location and looks at port number 80 on that container. Next, we have a different container here running. It runs the MySQL database server. It exposes port number 3306, not to the world outside, not here. It is not exposed, just within the container system, so that this guy can connect to the database and store, retrieve, and do whatever CRUD operations, CRUD, create, read, update, delete operations. It can operate on the database. This application will operate on the database doing create, read, delete, and update and delete operations on the database. This data, meaning the information that is stored inside the database server, which is also known as data, needs a place to reside, even if you decide to extinguish this guy. You can kill this guy, but you want the data to be protected and safe. And that is why we have constructed a separate data container. All it does is gives its disk to this guy so that you can save your stuff in my disk. Use my disk, please. That's the scenario. That's exactly what we are doing, by the way. And that is written down in this line in here. That specific linkage between database and data container is line number 7. Where I'm saying line number 7, by the way, is a part of this definition for the database, all these lines. So very small. Let's go read in the other file so it's easier to draw. Opening up that notepad one more time, Atom editor one more time, and looking at it slightly smaller fonts. Yeah. So you will see that here I build an image called data using a reference to a folder called data. And this data folder is right here, which has a Docker file in there. And that Docker file is like 3 lines. It says use Ubuntu, expose a folder var lib MySQL. That's where I would like you to store your data, dear database. Please store your data in my disk here. That's it. No other function. The command to execute is true. I mean, yeah, go ahead. Now do nothing basically. Basically do nothing. Just use my disk. In this folder I'm exposing to you, put your stuff in here. That's what this Docker file does for the data container. That's what it's going to be built, just like that. Docker file, just expose a volume, use my hard disk, put your stuff in that folder, You're welcome. That's what this thing will do. And now line number 12. It will use the volumes from the other guy, the data guy, the data container. Use the volumes from data. You mean use this hard disk basically. This data will use this hard disk in that location, which is defined in here. So what we are really doing is separating this container, its application known as MySQL Server, and the data it stores. We are separating the data from the database server. And what is the benefit of doing that? The benefit is as simply as this. Say, for example, this container dies. You want to protect the data. And this container, there is nothing to kill. I mean, it's already exited. That data disk is available to you. This disk, the container ID is exited container is available. Unless you decide to kill the disk, it's a different story. If the container dies for some reason, you don't want the data to die with it. And therefore, we are separating these two ideas here in a data container, separate from the database server. Now, before I demonstrate that the data is actually not lost, I want to put some data there. So let's go do that. In here, let's go put some data. So we'll say, yeah, let's go set it up. So we'll go give it some title. And save some data in there. And then I will prove it to you by killing the MySQL server that the data is not dead. So here I'm logging in. And once I log in, I should be able to go to the dashboard, visit the site, make some changes, make some entries. So instead of hello world, we'll edit this to say hello Cloud Genius and update. So that's the data updated, right? So we have the data there. Great. So this is the data. You see it right here. Now, let's go quick. Let's go kill the database server now. I'm going to extinguish this guy, line number 2. How do you kill it? Docker rm-f 529. This 529 number comes from the first few characters of the ID number that I want to kill. So I kill it. It's dead. I want to bring the whole stack up, just like I did to begin with. Docker compose up. It will rectify and correct anything that is missing. So when I run it, it says, yeah, recreating the WordPress application, creating the database, and starting the data container. That's data container being started, and it exited again, by the way. It will exit again, you will see it, like here. It exited again. Creating a Docker files DB container. This was killed deliberately by me. This right here, kill. And so I killed it, so it got created again. And since there is a new database container, the WordPress server, although was running just fine, but the connection between this container and this database is broken. So we have to now connect this container with this database container with 217F as opposed to this dead one. The link used to point to the dead one. So we have to recreate this WordPress container because the new link needs to point to 217F. This WordPress needs to connect to this guy, not the dead guy. And the data is, by the way, still in a different location. And I will now open the browser and refresh it. And the data will persist. And you saw that it is still has my data. I just refreshed and it still has my data. The data got protected because it was kept separate. from the database server. I can kill both these guys and still the data will persist. Let's prove it. So Docker rm -f ce and a4. Oh, no, not a4. I want to kill 2.1, not a4. A4 has the data. This guy, A4, actually stores the data. I don't want to kill it. I'll kill the other two guys. Dead. My WordPress site, gone. Let's go build the stack again. It builds. And now I will see what we have. We have these guys running. This guy still protects my data. It protects my data. It maintains the same ID number all across. See that A4. See A4 here. See A4 here. See A4 here. It is the same identifier. It does not die because I did not kill it. That's where my data is sitting. Now if I go here and refresh, I got my data back. Data is not lost. What we are doing in this example is basically identifying a method of how we separate concerns, not only between a database function and the application function, but also keep the data outside the application, otherwise known as MySQL server, and keep it in a third location so that we can protect the data, back it up, move it around, do whatever we feel like with it. That's the separation of concerns that I want to accomplish. And I just did in very succinct fashion. Not too much code, but concepts. Very clear that the application, WordPress, is separate from the database server. MySQL is separate from the data itself. This is user data. You want to keep it intact, keep it safe. So keep it separate, easier. Separation of concerns again. So that's this data container. You will also see now a little bit on the MySQL container as to what it is doing and how it is sharing and configuring some of the MySQL specific aspects. What we are doing is another volume exposure. What I'm doing is mapping a volume from the actual machine here, this machine, this one, over to a folder inside the container that contains the configuration for MySQL server. So this is specific to MySQL, and it basically allows anybody to connect from any other container. That's the configuration. Sorry, I accidentally deleted something. I'll bring it back. So what this line does, line number 14, is that it is mapping some configuration I've stored in here in my computer, which is exactly that location. So it is stored in etc MySQL conf.d containing one file. This one file is the custom configuration for MySQL, and the purpose of this file is to allow any container, any other container, to connect to me. So this database server, by default, does not allow anybody else to connect to it from the outside. Only you can connect if you're already inside. That's the default behavior. It does not allow anybody from the outside. That's how the design is. And that is okay in dominant use cases. But in the context of running in a container and separation of concerns, you want to allow this container to get connected to from another container running, say, WordPress or running some other application, for which you need to remove that no and make it yes, please let me connect. I want to connect from a different container over to the database server, but the default behavior is no. I want to say yes, please. That's what I want to change. That requires a configuration change. And that change is what I'm doing here in that file called custom myCNF, where I'm saying bind address any location, 0000. Just come from anywhere you can. As long as you can, You're welcome. Since we are running in a container environment, there is no way to connect to it unless you explicitly have a route to go to the container. And so this 0000 actually means anywhere within the container environment, not outside. So any other container basically can connect to it, connect to this MySQL configuration, provided this bind address is called out like this before the MySQL server starts. And you can say that in this configuration and expose the configuration from your real machine with a colon to the container inside. We are basically putting that configuration file inside the container, the MySQL container. We are also specifying some parameters, like I would like to use a password called secret. I would like to use a username called user. I would like to use the MySQL password as password and the database as DB. That's the name I choose. And this is what I define in the environment. Similar to that, what I will do is use these same details that WordPress will pick up. And WordPress will actually use the username, user, and password as password to connect from this image, sorry, this container, and it is already linked to the database container here by this reference line number 26. So that is the link that I have drawn in form of this green arrow, which is line number 26. And in here, I'm also exposing one other volume. In that volume, I'm basically putting any user-generated content, and I'm keeping it outside the container. So this folder that I have highlighted, home user Docker files WP content, is the folder where a user will send something, upload something, or create something. That's where it gets saved. By default, it gets saved in that location where www.html.wp content, but I would like to keep a copy with me on my real machine, on the host. So I have created this connection between a folder on the computer with a folder inside the container. So it's a colon B mapping, this colon that mapping. What it does is a folder here is mapped to a folder outside that looks identical. You create something here, it gets created here. You create something here, it gets created here automatically. It's a mapped folder. And you can see it in real live action by going to this site. Let's go see that. Where is my workstation? So I'll go to the workstation and I'll open up Firefox browser and I'll go to the login page. And there I log in. I know my password is 123123123, so I just log in. And then I will upload a picture. I'll say media and add new and select some files. And I'll say I want to send this picture somewhere. I might have some pictures here. Let's see. I don't think there are any pictures in the virtual machine, it seems. No videos, no pictures, no nothing. Media. No, I don't have any pictures. So let me download some picture, by the way. Yeah, that's easier. I'll just download some picture and then upload it to the site. So I'll just go to that picture. I seem to like it. Oh, page not found. How nice. I'll download this picture, copy link location, copy image, save image as. That's a good one. So I'll just download this picture, save. Great. So I've saved this picture in my computer, by the way. And I want to upload this picture as a user-generated content. So add new, select files, go to my downloads folder, that picture, go say open, and here it goes. So now I have my media library, has that picture. And I can see that. It's in the browser location known as this. So that picture is available inside WordPress. I can see it in the library and all that good stuff. But what happens if This picture, by the way, is not in a database. Remember, it is in the WordPress uploads media folder, which means it is sitting somewhere in here, line number 28. And so it is now mapped to a physical box, this box. In that location, home user Docker files WP content. So I should be able to just go to that home user Docker files WP content and then uploads and 2016 and October, and there it is. It just came to my real computer by this mapping that I have put. This is the mapping, line number 28. So if you go inside that container, you should be able to see it. Let's go see inside the container. There are these 3 containers running, 1, 2, and 3. Third one is exited. So it is not really running, but it is there. It has the ID number alive. I want to go inside this container and see that location where the file may be. And I want to go to that location where I should be able to find that file that I uploaded. So let's go enter that container. In a running container, you can just enter by typing this command. It is docker exec it, then the container ID, like CA, for example, and then give me a bash prompt in there. So you get there, you get the bash prompt. Now here you can see that you are already in that folder where WordPress runs. So you just go to downloads, uploads folder here. I think I have to go one more step, WP content. And then uploads folder. And then 2016. And then the month October. And here you should be able to see the same files. That's what got uploaded by the user who uploaded this media item. It is sitting inside the container. I am in a container called Charlie Apple number 5. I want to come out of it. I did. I want to now see all the containers I have running, and I want to kill both of them that are running. So docker rm -f, and I want to kill Charlie Apple and number 40. Both go bye-bye. Now I have only one exited container and not a functional site. This site doesn't function anymore. It is unable to connect. However, my data is not lost. Not only that, my images are also not lost. I can simply prove it by bringing the stack up one more time, saying Docker compose, bring it up. It does. It started the data container one more time. It created a database container, created a WordPress container, and now we should be able to see those 2 live containers. Again, port number 80 from outside, mapping port number 80 inside in the WordPress container. This container connects to the database. The database itself allows 330 export so that the WordPress can connect to the database. The database itself stores its data in a data container, which is this one, the same A45. And your files are stored actually on the real machine. So you should go here and then log in and go to that place where you have your media folders sitting. And I'm going to log in here. I know my password. So I log in and I should see my media files and I should see that logo right there. That is intact because it is sitting and mapped outside. I have managed to map it to a folder outside the Docker system. This is a configuration file provided from outside the Docker system inside the container in that location so that MySQL configuration picks up and allows connections to it from any other container. It has some descriptions here about choosing passwords that you would like to see in the runtime of that container. And that's it. That's it. It has a data store separate for the database itself. This data corresponds to the database. The files that get uploaded by users are sitting in that location on the real machine that are mapped to the virtual location, the container location inside. That's the entirety of it. I mean, there's nothing more to what we discussed. What you will also see is that this is probably a very succinct definition of a 3-tier architecture. So first tier is this, 6 and 7. The second tier is this segment. And the third tier is this segment. So 3 segments in a short 23-line code you describe, and you're able to construct something like a 3-tier architecture like you saw in my illustrations, like this, 1, 2, and 3. The data container at the bottom, database container, which is running a database server, and then on top, your application. Any questions on this before we go further and make it more complex? But again, we retain the ease of readability. We will retain the ease of doing things in a decent fashion without bogging ourselves down. But at the same time, we will make it complex. So we'll see these things. But I want to make sure that I answered your questions at this moment before I proceed forward. Any questions?
Yeah, quick question. What's managing your underlying connection configuration? I mean, you seem to be cutting stuff down, tearing it up. Who's doing that management? Where is it happening?
So Docker is doing it for us. So the connection between this runtime environment and this different container is managed by this line called volumes from the other container called data. And this construct is supported by Docker. And let us read that detail. So we have actually multiple different types of things that we did discuss briefly. I want to recap those things. So we discussed 3 different types of connectivity things. One was port mapping. Port mapping. So port from a real machine maps to container. That's how the mapping happens. The port number 80 here maps to port number 80 here. That's port mapping. Then there is volume mapping. Volumes from, specifically volumes from that mapping. This volume from mapping means that, you know what, use the volumes provided to me by the other container, this volume from. So we have a reference here called volumes from. And we are using the volume from a different container called data. And that container itself is exposing its volumes to other people. And so the other guy, which is the data container, it exposes, use my volumes. Use this var lib MySQL. Use this, please. I want you to use this. I'm giving it to you. Go store your stuff in my storage. It is exposing that volume. And this is what is being used here. And that construct is defined in our segment, volume from. Use that volume. And inside there, the build instructions say that, you know what, I'm exposing this volume. So please use my volume. That's the succinct definition of how this data is being secured and protected, even though you are killing containers left and right. Because you're extracting useful information, keeping it outside the container system. Volume from data. There are more things like this. We've done it right in this example. Similar, very, very simple, but it is not volume from, but instead a volume mapping. This volume mapping works something like this. Some real location, colon, location in container. That is the mapping. So you have some real location that you define and some location in the container which is expected to be when the container is running And that mapping is what is shown in the example with a picture upload. You saw that. I uploaded a picture here in WordPress that got stored in the location in the container. But since there is this mapping, that the picture actually gets saved here in a real location. So I can actually go and see that real location, like right here. Oh, no, not right here. Like right here, and go to the Docker files, WP content, go to uploads, go to 2016 and October, and there are these images. They are available locally, even when I destroy the whole container system. They are available to me because I kept them separate. I extracted every single thing that is of relevance to me from a user's perspective or an administrator's perspective and kept them out. What I'm really doing is that I am identifying from a service perspective, whatever I want to run, is there are things that needed to run the binary, right? Run the binary. Let's go binary. Whatever I need to execute. This is the executable. Right? It needs to be there at the runtime, so it runs and all that good stuff. But then there are people that come into play that will make changes. So they'll bring some content, delete some content, remove some content, or they'll do these CRUD operations like create, read, update, delete. People do this all the time. This is the administrator. And this is the end user. They will all do a variety of things. Mostly CRUD, depending on the permissions they have. So create, read, update, delete. Those operations end users will do, administrators will do, other types of people will do. They all based on their roles and purposes. You know, some users are read-only users, so they will not be able to update anything, but they will be able to read. They will not be able to delete. They will not be able to create, but at least read. That's the end user classic visitor scenario. The user needs to be able to read. And so depending on roles of a user persona, you will allow CRUD operations accordingly, but that CRUD is distinctly different from the actual execution, which has to be separated. The better you clearly understand what needs to be separated, and the more accurately you are able to keep it outside a disposable environment, the better off you are. So what I'm really doing in this example is very clearly identifying what is it that is repeatable and what is not. I see that a user uploading a picture is not really repeatable. A user will upload a picture one time on Facebook. I mean, they'll go to Facebook and upload here. They'll do it one time. They'll not come again and again and do it. Nobody does. I mean, nobody wants to do. That's how it goes. So, yeah, it is not repeatable. I mean, this is something that needs to be protected. Because people are not going to upload the pictures over and over and over again. I mean, people are people. They're not idiots. So this needs to be protected. Somehow, find a method to protect it. It is not repeatable. The picture will be uploaded only once. The customer is not going to upload the picture again. If you tear down the entire design, you're not going to get the user to upload the picture one more time. No, that doesn't work. So you need to really make sure that it is not repeatable, so you protect it. The second thing is to be able to identify what is repeatable and then write it in a fashion that it becomes reproducible quickly, efficiently, and it makes use of all those protected elements quickly. So if you think about, so these repeatable elements, I want to regenerate them as quickly as I can, regenerate as quickly as I can. And map back the connections that I have with those elements that are protected. Whatever I want to protect. So in our example, what we're really trying to accomplish from a protection perspective or non-repeatable perspective is things like administrator login. Admin comes in and logs in as Nilesh and types in a password 123, 123, whatever the password is. Yeah, so the user types in a password. This is like a one-time operation. Don't want the admin to go and type these passwords and create new user accounts over and over again. That administrator will get tired of you, because this is basically not repeatable. You create a password one time, that's it, you're done. This data, by the way, is stored in a database. This goes in the database. Similarly, the administrator logs in and changes a page from hello world to say hello Cloud Genius. That's what the administrator did. This is also a user generated change. And so you want to make sure that it is protected, because the user would not like if you change the page on them. Hey, Cloud Genius, no, it is world again. The user will dislike you. The administrator will start hating you. What kind of an application deployment is that? Why does it destroy my data? That's the question, right? These are not repeatable actions. Another example, we took a picture. The picture was uploaded to the library, media library. So the picture needs to be saved. And so we had to identify within the context of an application running in every single container, what is repeatable idea and what is not. Anything that is disposable, anything that is repeatable, like a box in the cloud, a container that runs your applications, whatever you put in there, the application themselves, they can be reinstalled. Who cares? You just throw them away if you want to. But design your structure in such a fashion that they are actually disposable. Make disposables disposable and actually throw them away, because you're really keeping the essence of useful information in a separate protected location. You're storing this data about username and password and page changes in a database. You're protecting this picture that got uploaded in a file system that is real computer, not a container, real host file system. Now you further saw me do this, that this database itself is also an application which is kind of disposable, because I can always get another MySQL server running. I mean, what prevents me from doing that? Nothing. I can always get another new MySQL database server, but do I get my data back? No, not so easily, unless you put your backup and restore procedures. And that is where I create another such thing, which is considered not repeatable, by separating this database pieces into two parts: the MySQL server itself and the data that goes inside the database. These two elements are separate actually. This is what GitHub gives you, is the MySQL server. And this is what user generates, like the username and password and page changes. So you can get this MySQL server very, very easily. You can go to, where is that site? Here. So go to MySQL, GitHub, you should have it. And there it is. So you have the source code right there. If you don't want to get the source code from this group of people, what you can do is, the MySQL server, what you can do is, you don't want to get the source code, no problem. Go to hub.docker.com and get the ready-made MySQL image. It is constructed by the same set of people. Just get that image. It's downloaded 10 million times. Same image available. Click, get it. Docker pull MySQL, you have it. Or Docker run it. MySQL, you have a runtime container implementation. You don't have to compile and build and assemble and all that source code dealing with. No need to. Don't reinvent the wheel. because there are lots of wheels already invented for you on the internet. So don't have to reinvent those wheels. All you need to really worry about is your user. How do I make their life less miserable? Because already it is miserable, right? Life is. And so you have to cut down work that they have to do by keeping the meaningful, essential things that they create out of the disposable system. That's essentially what I have done here in these examples. You see this in here. Actually, here. Data, one container. Database, different container. And third one at the bottom is the application container. So 3 different functions, 3 different purposes. The last 2 are what people mostly think about, but I extend that to the very first one on top, to extract data outside the database and keep it separate, which I think is a better practice. You want to keep the essence outside of the database and let the database run. And you can, basically think of it as, from what's the database called? MS SQL. You have this database, right? Your Microsoft, no, not this. Yeah, here, SQL Server 2016. This application. To get this to run, you need to have a Windows server, and then you install this server, and then you get a SQL server. Big deal, big deal. I mean, what do I do with the server? All I need to do is store stuff in there. So why do I have to go through all that? And why not I make it disposable in a fashion that I run one command says SQL Server 2016, bring it down, run it here right now, and here it comes. Because what I really care about from a usage perspective is my data that sits in there. I don't care about my SQL Server or neither this SQL Server or any other server, because they are disposable to me. I care about my data. And I want these tools to help me protect, maintain, use, and CRUD my data. C-R-U-D, CRUD. CRUD doesn't mean this. That's the English meaning. CRUD means this. So read that CRUD, because that's what I really want to do in create, read, update, and delete. That's what CRUD, essentially, to me, that's what it means. Although in English language, it has a different meaning. So you can disambiguate that if you like. But that's what my CRUD is. It's what I do with data. And so that's what I'm really doing with the design in a fashion that I'm separating out data, the actual useful aspect of whatever I have here. The SQL Server, it's a big product. It runs nicely, but the users don't really care about the product, honestly. Whether it is this product or whether it is Teradata product here, or some other big name company that produces gigantic big software like Oracle database, for example. People honestly don't care about this server, the Oracle database server. They care about their data. And so you really have to worry about that piece, is take this into account, take this guy into account, because it is their data. That's what they are trying to protect. It might sit in some Oracle server, or it might sit in your Microsoft SQL server, or it can sit in MySQL server, or it can sit in PostgreSQL server, or God knows where it is. I don't care. These are all irrelevant to me. I care about this. And that's what I'm really trying to protect. Because these things are disposable. I can throw one out and bring the other one, and as long as I have my data and I can use it and I can CRUD on it, beautiful. That's what users worry about. Not whether I have Oracle or whether I have this, because it's irrelevant. Honestly, mostly irrelevant. Even this Teradata. Many companies use this one also, but yeah, whatever. So that's the answer to your long answer to your short question, which is why are we doing it this way? Because it helps the user. That's the reason why we do it this way. Further questions on this? No questions? Are you there? I was just talking
No
alone.
questions.
No questions. Okay. Do you want to take a short break before we extend? Let's take a
sure.
short break, 6:45. So right now it's 6:41. We resume at 6:45. In the meanwhile, questions are welcome. I'm sitting here. Is this discussion useful in terms of the layered structure that you saw in running a 3-tier architecture? Is this conceptually different from what we did before a little bit? Are you there? I think you must have gone on break or something. Let's see. Diego. Hey, Diego, are you there?
It's okay, it's my choice. But bad choice, and it's not okay. Sorry, I didn't know. Nobody does. I was embarrassed, so I didn't say anything.
Are we that friends?
Hey guys, I'm back.
Another one.
I'm here.
Okay, awesome.
I know.
Good to hear.
It's also why I never open the
Any
door
further
without
questions on this discussion before we proceed forward? I guess not. I guess not. So what I would like to do now is introduce another tier. So what I'm really doing is we discuss these 3 tiers. I'm just introducing.
Yeah. Okay.
Okay. So what I'll do is I muted everybody, by the way. So what I will like to do now is introduce another tier. a tier that I will include primarily because I want to route traffic according to user's desire. So this user that sits somewhere and visits some location, like some name or some IP address, one of those two. I want to be able to route traffic of users based on names, not on IP address. Because nobody actually visits sites on their IP address. They visit by name. I want to go to, say, CNN.com. So show me CNN. That's how people visit, right? And so that's what users do. So I want to put names and associate them with a variety of services. So here I want to run my service to do XYZ. Here I want to run my service to do ABC. And here I have something as PQR and some other service, LMN, like this. So some random services I'm running in some bunch of containers, maybe multi-tiered. I don't know how many tiers, but all I know is that I have a service endpoint that I'm running something on this container, and the name happens to be this. That's the name I'm using. That's what these users will call them by the name. Call by the name. So I have a service here that I want to use called CNN.com. So I go to CNN.com and the site opens up. I have this other service called NY Times that opens up when I type NY Times and I see this site. That's beautiful. But how does this thing actually translate to what we are going to show in the next layer of architectural stack? It's a multi-tier architecture, and we are introducing one more tier. That's what we are really doing right now. So it is introducing one more tier, so a new tier. That tier I will like to call a proxy. And what this proxy tier will do is basically look at what the customer is asking you to do. And then accordingly, if the customer says, give me XYZ.com or whatever, .com is irrelevant, just some name, then the proxy will look at the incoming request and say, oh, I know you're talking about XYZ. Aha, I remember. It is here. So I should take your traffic and just send it over here. This other user here that says, give me ABC, please. The same IP address here. One IP address. But different names. Same IP address, different names. This name, that name. One shared IP address. One common location. One common endpoint, which is a proxy to a bunch of services I might have running under the proxy. So if the user says, give me ABC, this guy, then the proxy will make that decision for the user and automatically know that, hey, I know ABC runs here, so I should route your traffic to this. And let me connect you to that service endpoint. That's the kind of function that I want to introduce as a new layer. And this thing, using a new layer like this, is called reverse proxy, by the way. It's not just proxy, it's called reverse proxy. So I should rename it differently. It is called reverse proxy. Because a forward proxy is a different thing. We'll talk about forward proxy at some point. I'm using the function is reverse proxy. Letting the user decide where it wants to go, and based on the name, I will transport the traffic over to the appropriate service endpoint. And that is the new tier that I want to introduce. And that is what I will do in the next exercise. So we have this that we have constructed in this Docker Compose YAML. I will erase all that and basically save. So this change that I made here is all blanked out. It's an empty file, which means if I now run docker compose -d, it will be a disaster. It has nothing to do. I mean, it's a disaster, which is fine. We just know what we're doing. So we are going to kill everything, including the data. So we are going to actually extinguish our data container as well. That's what I intend to do. So basically cleaning up, making room. I made a mistake. So I'm cleaning up, made room, and now we have nothing running and no containers running there. There we go, nothing. If I run docker compose up right now, it has no meaning because it will do nothing because there is no such file, nothing to do, and so it does nothing. It's pointless. Don't do it. Back in here, in the docker compose YAML, which is empty, I want to put in a slightly more involved example. So I'll bring up this file called main examples. And that is what I want to copy the whole thing and put this in the docker compose YAML file. So save here. So now I have a docker compose file, which is slightly more complex than the 3-tier example we saw before. So there's a 1-layer data tier, 1-layer database, 3rd layer WordPress, 3-tier. Not that one, but slightly more involved, which is what we have extracted from this main examples collection. Put that in this folder, in this file called docker compose YAML. Here you will see that there are a variety of different services already called out. They all construct something interesting. And I will walk you through in terms of what these things are and then actually run it. So I have this thing. What I want to be able to do is just run it for now to just give you a perspective on what's going on. And while it runs, I will talk about it. So it is doing its thing. Now let it do. On the side, we'll go read. We'll go read what it has. So we'll let it run. It'll do its thing. It'll do quickly. It should not be taking too long. But let's read what we have. So in here, we have a container-based Nginx reverse proxy. Container-based, meaning it's inside a container. It is a reverse proxy like I described to you just a few minutes ago. And it is called Nginx proxy. It is created by a person by the name Jason Builder. And that guy is this person. Let me just show it to you. J Builder, Nginx proxy. And that is this gentleman who has created this proxy. And that is a very well-known proxy, at least well-known to me, I should say. It has like the thousands of stars, and so it's actually pretty active and pretty well used. It has 46 contributors, and the purpose of this project is to create a proxy inside a container. And our purpose of using this is to actually illustrate the point that we can create another tier. Then we are basically increasing the complexity of number of services that we will be running inside our environment in some cloud somewhere in containers. And we will basically understand the things that go along in assembling components together to create a much more elaborate set of services that we would like to have for this guy and for this guy, the customers, right? They want to access services, we want to give them services. And we are constructing a reverse proxy based container to let them access a bunch of different services that I want to run. So back here, By the way, that thing finished, which is nice. So it quickly did. So that run, the Docker Compose up is running now. Nice. So let's go see what this segment does. That's the container definition, succinctly defines that I want to run JSON Builder's Nginx proxy container. And by the way, map port number 80 for a real machine to the port number 80 inside the container. That's the mapping. Port number 80 on the physical machine to port number 80 inside the container, which is this container, Nginx proxy. Excuse me, which is the Nginx proxy container, this one. And that's how the mapping is going to be. Basically, what this means is this guy opens up browser, goes to port number 80 on the box that you are running all these services on. And so you have a container here. This runs your Nginx proxy. Our usage of Nginx in the past has not been the proxy usage, but more like a web server usage. In this example, we are using Nginx as a reverse proxy. So this proxy container that we have is exposing its port number 80 to the box port number 80. And that mapping is established in the compose file right here. That's it. That's the only mapping for ports. There is also a file mapping, a volume mapping, which is this file from the real machine. I would like to map it to this location inside the container in read-only mode. So what I'm really doing is exposing this file called docker.sock, which is the Docker socket, and providing that as a read-only access to the file tmp docker.sock inside that container. That's the design of that particular reverse proxy. And that is what we are basically following documentation provided by Jason in this location for that image. That's a requirement of that particular image. So we are filling that requirement by including line number 7 and 8. In line number 9, we are saying use that image. And when it dies by accident, restart it. Restart always, line number 10. That's it. That's the definition of the entire container reverse proxy, and it will do it for us. Next, we'll look at our next container. This second container that you probably have seen already at the beginning of this discussion today is Tutum WordPress. Now this container is a all-in-one demonstration container, not good for production because everything is running on one container, including the database and MySQL and data and all of that, all on one container. It's a bad design, not good for production, but we are using it for testing, for illustrating. The idea is that this is a service called C1 that I want to run in this fashion. And let's rename this C1 to something like cnn.com, for example, to make it more interesting. And here I will say it is cnn.com. And I will have some fun with it, by the way. So I'll make some post modifications and have some fun. So cnn.com is a service that I want to provide inside my container. It is not going to be the real cnn.com. It's going to fake it. I'm going to fake it, by the way. And this definition of CNN is going to run WordPress on a one single container, running the same container runs the WordPress application, also runs the database server, and also stores the data. It's a disaster to store everything in one location, in one container, but that's how this is. So just to understand that that's a bad design, but that's how the design is. So just live with it for now. That is this container called Tutum WordPress. It's a demonstration application, basically. So it's not a production. But the demonstration we are using, Tutum WordPress, as a fake cnn.com. Fake. It's totally faking out. And I'm saying that, you know what, expose the port number 80 this container will expose the port number 80. So I'm basically having one more container here. I'm calling it CNN. And it is exposing the port number 80. It is not mapping it all the way to this box. That's not how it is. No, not that. Just exposing. The only mapping we have is this blue line. This is just exposure. I have a service here called CNN. That's it. Nginx proxy will look for all these containers. What do you have, guys? Let me know. What do you have? So we will create a New York Times now. And that New York Times container will also expose my port number 80. Hey, I also have a service called New York Times. Bingo, great deal, big deal. I have another service here. We'll call it like timesofindia.com, for example. And this guy will also say, I also have a service called Times of India, and it seems to run on port number 3000. And here, one more. I have another service, let's say, call it Times of London, or Time Magazine, simpler, Time Magazine. And this thing says, I want to expose my services to the container system at port number 80. So I'm basically faking out 4 different sites and exposing them in different ports. Like this one exposes itself on port 80, this one 80, this one also 80, this one says, I want to expose myself on 3000. Fine. And that is Times of India. And so these exposures are happening inside the container system, and this Nginx proxy will detect, hey, what do you got running? Oh, you got 80 there? Nice. What's your name? CNN. Okay, I know. What do you got? 80? New York Times, I see. Times of India, 3000. Nice. Time Magazine, port number 80. Great. And what we will do is actually under the hood run a variety of services that will attempt to fake these different names. So I'm just taking these names for convenience. There's no particular meaning to this name. I can use C1, C2, C3, C4 as well, just for example. In fact, that's what I have in the original design. I just use the names C1, C2, C3, C4 like here. But to make it more interesting, I'm changing the names to CNN or CNN.com, for example. Just making it interesting, nothing more. Next, we have a slightly more elaborate container system, which is actually our 3-tiered architecture we saw in the previous step. So 3 steps. We have a data container, we have a MySQL database server container, and the WordPress container. So 3 containers together form a new service that I will call the New York Times service. So this in turn actually is 3 different containers that I should draw them out very clearly that look like this. So there is a WordPress container. Oops, bad pen, wrong pen. So there is a WordPress container, there is a database container, and there is a data container. Just like the design we had before. And it connects like this. And this guy exposes itself on port number 80. Except it doesn't actually connect all the way to the real box, just exposes itself. Here is your New York Times. Take it. And so Nginx proxy will say that, hey, you seem to have a port exposed by the name New York Times. I see. I'll keep track of it. Here, we will have another different software called Redmine. It's a different application. I'm going to run it in a container. And I'll pretend that it is Times of India. Just pretend. So we will use Redmine as a different container, but I'll pretend that it is Times of India. And here we will have another software, another famous open source software running in a container. The software is called Joomla. And that I will pretend to be the Time magazine. Just pretend, and exposing port number 80. And so this Nginx proxy will look at 4 different containers. One, you got CNN on port 80, great. Times of New York Times, port 80, got it. Times of India, port 3000, got it. Time magazine, port 80, got it. So I got 4 services to deal with and to serve 4 services to this guy. Okay, let's go back here. So we have constructed this container with Kutum WordPress and called it CNN.com. Now we will construct a multi-tiered, 3-tiered architecture with WordPress and call it New York Times. We'll do that right now. So here is C2. I'll call it New York Times. And the host name I will modify to be newyorktimes.com. It links to a database container that runs the MySQL image. And this MySQL image is exactly the same that you saw before. And it stores its data in a data container. Here. That's exactly the same thing you saw before, nothing different. Same exact thing, data here, database here, and the application called WordPress up on top, which is going to pretend that it is New York Times. Pretend New York Times. Next, we are going to construct Times of India, or rather Joomla here. So Joomla was what? Time magazine. So we'll say here, your Time magazine. And the virtual host entry is time.com. This guy, image uses Joomla, uses the Joomla image, which in turn also requires a database. So what I'm doing is using the same database we have in here. That's it. And so what I'm doing is this Joomla, you need a database. Oh, you use this. So you can share the database if you like. Don't have to, but you can. And you can put a separate database if you want, isolation, and have its own data stored separately. You can do it like this and connect it like this. But in my example, I've chosen to not do it this way, but use the existing database that we have already for WordPress. So just use it. And everything else remains the same. This Joomla is going to use the database link that is already there here up on top. That is going to pretend to be my Time magazine. Next, we are going to construct and fake out this thing called the Times of India. And the virtual host for that will be Times of India. Now this thing, actually the application itself is called Redmine, which is a famous open source application. To you can read more about what Redmine is. So here it is, Redmine. Not Redmine, but Redmine. And Redmine is a project management application. Flexible project management web application written in Ruby on Rails framework. That's what this is. And it requires a different database. This Redmine doesn't use MySQL. It requires PostgreSQL, PG. So you need to have a separate container to address the database needs of this guy. And so we will create that PG container also to service the Redmine application, which is what you see here. This Redmine application image runs and exposes itself on port number 3000. That's convention in Ruby on Rails. You can change it but that's just the convention. It links to a different database called PostgreSQL, which is running here. And it uses the image called Postgres with the username called Redmine and password called secret in the environment defined for that. And it runs that particular PostgreSQL container, so separate data container, the database container. And by the way, you will notice that I have not bothered to create a separate data container for this database. Like, let me clarify that. What I have not bothered with is to construct a separate data container for this guy. Means if this one dies, you lose the data, just so you know. I have not bothered doing that in this particular example. So I'm calling it out. It doesn't exist in the example. That means if this container dies, you will lose data. And that's okay, at least for the example. Now, that's what we have in the design. We have constructed this layout in this file. Let's go review from all the very top. Review. Nginx proxy, which is the front end layer. It decides who's running where and exposes appropriately. We are running CNN, actually running WordPress, all in one container in this segment. We are running a 3-tier WordPress application in the next segment and calling it New York Times. It has 3 parts. The first part is the WordPress application, which begins here. The second part is a database server. That is this segment. And the third part is a place to store the data for the database server known as MySQL Server. And that is this part. Next, we have and by the way, we are calling this one NY Times, New York Times. The next container is running Joomla application. It is sharing the database with the New York Times. This one, this data and the corresponding database. It is sharing the same one. This Joomla shares the MySQL server. And since I have it already, I'm just making a connection to it through the design, which is, let me draw it one more time to make it clear. So we have CNN that runs all in one WordPress, all in one, just one. Then we have New York Times that runs in a WordPress container, then a MySQL container, and a data container, so 3 containers. Then we have this thing called Joomla that is actually running in, what's it called? Joomla is called what? What did I name it? Time Magazine. So we have Time Magazine that runs Joomla, another application that uses this database. And then we have a third one called In Times of India. Times of India, it runs an application called Redmine, and it requires a database called Postgres. So PG is running here. That's the design. And I should have another data container here that protects the data from Postgres, but I did not bother to write it. I'm just calling it out. You should, if you're doing it. And you should also not use this stupid design. It is just a bad design, but I'm just calling it out. This kind of sharing is okay because they're using separate tables. WordPress and Joomla, separate table space, separate namespace. However, certain times customers don't like that. And if that is the case, which is very likely the case, by the way, it is better to just give it its own database. Very likely customers will complain that Time Magazine data is sitting on the same database that New York Times runs on. Are you kidding me? Don't do it. Yes, they're right. Don't do it. Do it like this. But I'm saying that I have not done it that way in the design. I'm using it because I was being lazy. Don't be lazy. Just saying. I have not done this either. You should do that. Having said, this is the design we have currently. And these guys expose port 80, port 80, port 80, port 3000. We also have one more container. It's called the Nginx proxy. And this guy is basically the proxy looking for these open exposed ports. Hey, what do you got there? CNN, New York Times, Time Magazine, Times of India, great, bingo. That's the layout. So now that we have changed this file a little bit, and I'm going to save it and close it and come back here and see that these containers are running. There are lots of them. Let's go see what we have. By the way, I need to kill all of them because they have different names, C1, C2, C3, C4, and I don't like that name. So I will basically kill all of them and create one again. So that's what I'm intending to do. So here we have this file. I'm going to say, you know what, all of you guys should die. So go bye-bye. They are dead, all of them. And now I will say Docker compose up. Bring it all up with the new names I have, New York Times, Times of India, CNN, and all that good stuff. So here it is. It's all running, up and running. Docker ps-a. And we will see what containers we actually create. We have the first container called JSON Builder Nginx proxy image. It is exposing port number 80 from the real computer to the container inside on port number 80. Then we have a data container, which is successfully exited. It has done its work. And it is this DD75 container, which stores the data for this container, the MySQL container. This is the container which is used for database server known as MySQL Server. And it is used by the WordPress application as well as the Joomla application. These two are separate containers running here and here. They are the New York Times container and the Time Magazine container. Both are using the database known as MySQL. This MySQL server exposes itself on port number 3306. So that these applications, New York Times, which is a WordPress application, and Joomla, which is Time Magazine, both can access this port, which is the MySQL Server port. This server stores its data in this data container. Now there is this two-tone WordPress, which is a stupid design. It's a demo design. It exposes these ports, so the port number 80, but there is no mapping to the real machine out there. The mapping to the real machine is only for Nginx proxy, not for anybody else. There is no 0000 anywhere else except this line. That's the only endpoint that you can access from the outside. This service, two-tone WordPress CNN, runs everything on the same box. That is why you see the port number 3306 exposed, because it is also running a database server inside the same container, which is a stupid design. I said that. And so that's what we have here. We also have another separate database exposed at a different port, which is the standard PostgreSQL port 5432, which is used by Redmine. This Redmine application running for Times of India is connecting itself to the database known as Postgres server, which is storing its data locally in that same container, which is a bad design. I should have a separate data container even for PostgreSQL, which I did not. And that port 5432 is exposed so that Redmine can connect to it. Redmine itself is exposing port number 3000 to the Nginx proxy. All of these ports are exposed so that the proxy will look for these and share it to this endpoint. Now, we will go and actually fake these names out. The Time Magazine and Times of India. If you open these sites right now, let's go open them one at a time first. Let's go to first one, time.com. No, not time.com. Open. You see the real Time Magazine. What about Times of India? Typo. You see the real Times of India, right? You go to CNN.com. You see the real CNN. And similarly, you go to nytimes.com, you see the real New York Times. This is all reality. Now I'm going to make some hacks to fake these dummy sites that I have created for us. And that hack is basically a zone file hack. You've probably seen this before, but here it is. This hack, I'm modifying my host file, which is sudo vi etc hosts, and typing the password of Cloud Genius, and then editing the host file, which is as simply, I'm saying, okay, I made a mistake, so I'll do it again. Again, I'm going to the bottom of the page, open, and then typing localhost 127.0.0.1, and I'm saying that, you know what, CNN.com runs here, Time Magazine runs here, New York Times also runs here, and Times of India also runs here. Are you kidding? And I'll say, yes, I'm kidding. This is a joke. This is an exercise. So that's the hack I made. I'm going to close it out and quit. Now we will go back to the browser and open one of these sites at a time. So let's begin with what our design was. We want to open CNN first. Here we go. We go to CNN and refresh. When we refresh CNN on a new tab, I think we have to clear cache. I think it is cached out locally right now. So I want to actually open incognito mode as opposed to these modes. So I'm going to open incognito, which is here. Come on, incognito. There we go. So in the incognito mode, it should not be caching anything. And now we'll open cnn.com. And you will see WordPress. This is the Tutum WordPress that you saw. So we'll just finish up installing. We'll call it the cnn.com and username. Oh, I made a typo in the password. I need to go fix that. Just say 1, 2, 3. And so here I'm going to fake out cnn.com, and here we log in. So Nilesh and password, and this is our cnn.com. I mean, are you kidding? But no, it is cnn.com. Here you see that. Great. What about the next? The next one is New York Times. Let's go see that. So open new tab, nytimes.com, enter. And what do you see? What do you expect to see? You expect to see this 3-tiered architecture. That's what you see here. And so we'll go down and say, okay, and fill it up. We'll call it newyorktimes.com. Username and password. And log in. And this login is our different site known as New York Times. We visit that site. It looks like New York Times. Then we will open the other magazine called Time Magazine. So we'll go to time.com. And here, what do you see? Joomla, because that's what is running there on port 80, time.com. And similarly, the last one, timesofindia.com. And what do you see? You see Redmine. That's what is running here in Redmine. So what you saw in this layout is this new tier that I introduced, which is a reverse proxy layer, which is basically doing what you think it is doing, which I think is clear. But if not, questions? No questions? Okay, cool. So what does this mean to real life? So, nobody actually hacks like this. So hacking is silly. This is not how, this hacking is of no use. So what's the implication in real life? In real life, implication goes like this. First thing first, you want to go back to that host file and remove that idiotic entry that I have, which is this last line, dd. I think I made a mistake somewhere, maybe. Do it again. And delete that last line, which is a hack. And close. And quit. So in real life, nobody does these hacks. But then why was I showing you all this thing? And what's the point? The point is like this. In a company that you might have, let's call this, the Microsoft company or the Boeing company or some other company. That's not the point. The point is if you have some services running here, a variety of them. You have service number 1, service number 2, service number 3, service number 4. You run them in 4 different containers. And you can call them, service C1, service C2 like that, and map them to c1.domain.com and map it to c2.domain.com and like that, c3 and c4.domain.com, like that. You can map these things accordingly and put DNS entries in a real DNS server, not a zone file hack, not a host file hack. Then it becomes suddenly interesting. You can have multiple services in one domain running a variety of services for your customers, and you see that all the time. You see this in here, portal.office.com. It's a classic example. You have a web portal and you can log in and all that good stuff. And it goes to a different site and comes back to portal.office.com, which is basically a service running at this location. And that location happens to be portal.office.com. Now, this is different from office.com, which is the customer facing or rather market facing. It changes the site. I'll go to office.com again. If you go to office.com, it goes to this site, which is where Microsoft sells Office 365. This is not the portal site. This is a completely different site than what you see when you go here. On the left side, what you see is portal.office.com, which is the internal portal for Office 365 customers. Whereas on the right side, you see the marketing site where Microsoft sells Office. And it is a different location. It's www as opposed to portal. Like here, we have in this example we're talking about, the idea is office.com domain and 2 subdomains. One is called www, where you are selling stuff. And the other thing is called portal dot something, portal.office.com, www.office.com. And this subdomain, you are actually providing service. So this is a selling site, service site. 2 different sites, same domain. And there is a proxy somewhere. It may not be the Nginx proxy, but there is a proxy running in Microsoft somewhere on the Office domain that actually distributes services like this and connects things accordingly. And you will have the Office 365 service running here and the website selling the product in a different location running here. That's the connotation of this concept, running multiple services on a domain shared and proxied, reverse proxied like this. And all of this we were able to do in simply by constructing a file that is this file called Docker Compose YAML. It is not terribly long, not too complex, actually pretty darn simple to understand. And you are able to construct a multi-tiered architecture with one command like this. It does. It is done. It refreshed the entire stack based on what configurations you provide in the Docker Compose YAML, and it finished updating the whole thing. And that's what container technology can do for us and is doing for us. And so you will see more examples like this as we proceed forward. At this stage, I would like to actually take pause and actually ask you for questions, for feedback, for how was this? Was it useful? Was it interesting? Did you try it? All of those things. I want to hear from you. So please open your microphones. And talk.
So today's session I didn't do it, but I was mostly following what you're doing.
Okay. Was it easy to capture and understand the concepts?
Yes, it was.
Okay. Did you get something interesting or was it boring?
The Docker Compose is pretty interesting, actually. It is very easy to spin up whatever kind of architecture
Yes,
you want. You can spin up containers with that.
Yep. In fact, this extension of Docker Compose is Swarm, or
Docker Swarm.
Also known as a. So what we did in this example is all of these things were running in that one little box, right? Which is our virtual box. And we can extend the same concepts, conceptually extend, to run across multiple boxes. And that becomes the concept of Swarm, which is a fairly recent product, like 2 months old, 2 to 3 months old, probably. So it's a very recent product that has come out from the same team, Docker team, called Swarm. And you can basically run the same scenario across multiple boxes and scale it out comfortably, which is a very nice implementation, I think. And that's what the file looks pretty much similar to this. And we'll do more exercises in the context of something as we build, as we go along, as we proceed further. So what I want to be able to talk to you about is this. Where is that? Hold on, let me pick it up. Not this. By the way, other questions are welcome. I am thinking of making sure that I cover everything that I wanted to in the DevOps section. There are many things that I have actually skipped. For example, this concept of running your own chef server, like you saw, which is a very interesting and very practically useful scenario, which I did not cover, which is to build your own chef server, because the chef server you get from that company is for free, is limited to only 5 nodes, which is not a scenario that is a practical scenario. So here are 2 implementations of running your own chef server. There is a older version and there is a newer version 12 available. Both of them, there are different methods for setting them up. And the examples that are given here, I think you should try. And they are basically using Chef to run and manage Chef server. So it's very meta, using Chef to run Chef. So that's what this exercise does basically is you use Chef to run Chef, and that Chef run will install Chef server, and then you switch over to using that Chef server. So that's what we will do, is to use Chef solo to install Chef server, and then we switch over to using the server. That's the scenario. So you should do that. That's what I'm saying. You should actually run these exercises on your own if you want to conclude that discussion on Chef, which I skipped because I wanted to cover other things like Ansible and Docker a little bit, because these are much more interesting and much more simple to actually orchestrate and play out, much less complex to understand. And that's why I focused, I think, last 2 days primarily on those two topics, which is these two, Ansible and Docker. We'll do more of these things as we proceed along. There is new content I'm developing to make sure that you get access to, and at least I will describe that to you, even if there is not clearly written down steps in this site here. It may not have it because I'm building them. They're new technologies, but the bottom line is that we will cover it with you. I will at least give you a live demonstration and give you the source code for you to run yourself, even though you may not have written down steps like we have for some of the older exercises, primarily because some of these technologies are relatively very new. For example, the Docker concepts I described and the Nginx proxy connections and things like that. It's a fairly recent method of connecting using Docker containers, and the concept of keeping your data separate from databases separate from applications, and being able to spin things up without losing data, destroy and recreate without losing data, because you're really keeping your concerns separate, keeping them out. And I think I mentioned this a long while ago with you guys, where I was using this application to demonstrate that point, which is you don't want to put your useful user-generated information should not belong here. It should belong somewhere outside. I think I mentioned that to you a long time ago, right? So that is what essentially is what I'm accomplishing. And these are not boxes, these are Docker containers. So in our example today, they were containers. Not machines, not VMs, because the world is switching to using containers left and right, not too much into VMs anymore. Yes, it used to be useful. It continues to be useful to a great extent, but the switch to container technology is happening already. And there is no point in sticking to this old method of operating, which is why I am completely revising my curriculum, the entire program, to focus primarily on container technology. That's why most of my newer examples are not really about VMs. They are on containers. Okay, let me see if I missed anything that I wanted to cover today before we close our discussion today. We still have some time left. That's my concern. So I'm thinking of what did I miss? Probably not. But we will start the next time we meet, I think is, hold on, where is that? Where is the calendar? Oh, there. So the calendar is, we meet again on 20th. And what I want to be able to do is, at that day, we will begin discussing the other concepts of architecture. Is that right? Did we cover 8 days? I think so, yeah. So we will start architecture the next time. And at that time, I would like you to review. You should have access to the architecture segments already, I suspect.
Yes, we do.
So there is not too much to read. There are not too many hands-on exercises in there, but there are some. There are some that are different, but there is more of a discussion. So what I would like to suggest to all of you is to please discuss and participate. Please keep your microphones open and active, and please speak. Please actively ask questions, because that's the time to ask questions, because we have 8 more days left starting from 20th. when we will
So
meet. And that
I have one question.
Yes, please.
So in any of the remaining sections of DevOps or in the architecture, are there any exercises like case studies kind of thing that we'll be
Yes.
doing hands-on,
Yes, there is
building some
hands-on.
hands-on solutions?
There is hands-on, like for here, for example, foundations. There are some Docker examples here. So the Docker multi-tiered architecture is actually mentioned in this step number, module 7 is what I think I covered today, is here, module 7.
Right.
That's what I seem to have covered. And so we have more such, like here is a complex one, deploy N-tier architecture with Docker on AWS. And so that's a fairly complex exercise. It doesn't look complex here by looking at it's just one page, but if you go and understand what it is doing, it is basically automating what we already did by hand. So you remember long time ago, I mean, not so long, but long time ago, in the section on cloud technologies, we had a pretty intense discussion where we did a lot of things in module 11, data center in the cloud. And we went about understanding VPC and security groups and all that. That you've seen this, you've done it. The same thing like we do by hand here, we will do through automation in a subsequent exercise. So we have that one quite intense, which is in the architecture segment and the N-tier architecture exercise. There's a lot more things to do in that segment. We have some SSL-based concepts that are new to some of you, maybe in terms of automating SSL generation. We have discussions on OpenStack. If you have interest in that, we should do that. There are some exercises that you would like to do. If you happen, you need a big box. I think most of you do have a big box. So you should be able to run OpenStack on yourself, and I'll give you links for that specifically. We'll also cover case studies on a variety of topics in terms of understanding best practices, in terms of studying a variety of scenarios of usage of cloud. Take case of Netflix as a company. We'll take more examples and understand from a user's perspective, what does it take to take that application and run it for them in the context of some cloud. That's the dominant discussion. It will not be too much deep in the woods like we had in the DevOps section, but it will be more conceptual. And yes, we will have corresponding deep downs for those of you who are interested in going deeper. We will have that. So that piece, if you want to go, you can always go further explore with me. If you want to go do a one-on-one specific exercise you want to accomplish, please do that. And the overall discussion around the architecture segment will be a little bit higher level compared to what we have been dealing with up until now. So in the DevOps section, we were really deep in the woods, specifically with the chef exercise, which we really went granular all the way to the bottom layer and in basically configuring every single thing along to construct higher level stack, because that gives us a deeper understanding of what goes in building these things. But once we have that depth, we can then talk conceptually and actually put things together. Like we ran 4 different services in one stack, just like that in here. And that was not too bad. I mean, it was doable and not too complex either in terms of understanding what we are doing. It was not complex, just one file, basically, the Docker Compose YAML. And it describes all these containers in a succinct fashion, and you run it. And it runs. That's the idea. So with that, questions are welcome, and we will meet again on 20th when we will continue our cloud architecture discussion. But I am here for questions.
I guess no questions.
Okay, so let me make sure that I have given you a link to that exercise today. And so I think the link for Docker files, this link is the right link for the exercise that we did today. So you should play that. It's a very simple one. This last one I just gave you. A very simple exercise. We just saw that in great depth as to how it constructs a multi-tiered architecture complex with multiple services running on the same box. You can expand that into multiple boxes if you like, for real. But for our example, it runs just on that same little virtual machine that we have. And we have 1, 2, 3, 4 services with a varying degree of complexity running. And I think you should run this exercise because it gives you that clarity and understanding. And what I would suggest as you modify, that you please make little changes to it. Like for example, I would like you to run this same exercise, but not share the MySQL database. That's the simple step. I would like to construct a separate database container and a separate data container. That's what I would like you to implement for Joomla. That's the only change I'm suggesting, not making it too complex, but think like that. Is what would it take to modify this exercise so that the Joomla container gets its own MySQL server in a separate container and a separate place to store the data. That's the change I would like you to do on your own. And that's a modification. So play with it. Play with it and come on chat, see how you can pull it off. That keeps 2 different locations to store different services, New York Times and Time Magazine, separate databases, separate data containers, so completely isolated. That's how you should, when you run, you should run it like this. You will need to make a change for that, but I think you can do it. Cool.
All right. Thanks.
Okay, then if there are no questions, I will stop recording and let's reconnect on 20th. Then we will continue discussing cloud architecture. 20th, 5 o'clock. And 21st, we are getting together at that location. As you know already, you must have an email from me on that date and time. And we are gathering together for dinner. That is on 21st. So that is Friday. But before that, we have a class on 20th. Which is?
Yep.
Thanks. Good night.
Okay. Thank you, guys. Bye-bye.
Thank you.
Thanks.